Okay, so our group did number 12 on the accumulation review. Part B is the first one. So using correct units, explain the meaning of the interval from 10 to 70 VTDT in terms of the rocket's flight. Use a midpoint. And the midpoint Riemann sum gives an accurate area under the curve because left and right can be an over or underestimate depending on which one you're using and if the slope is increasing or decreasing. Now Kamal is going to explain part B.
To elaborate on the calculations that we did to achieve our answer, we did 20, which is the bases, the combination of the bases, times parentheses v of 20, v of 40, and v of 60. Right, so that accumulates into 20 times the parentheses 22 plus 35 plus 44, which equals 2,020 feet. So this means that the rocket has a displacement of 2,020 feet between 10 and 70 seconds.
So here, the acceleration of the rocket B is a of t equals t over square root t plus 1 in feet per second, so it's per second squared. So with that, and we're trying to find velocity as shown at the end. So the way we do that is by getting the integral of acceleration, because velocity is the integral the integral of acceleration. So we find that by right there, and the integral is 6 square root t plus 1 plus c. We can find the value of c by setting it equal to 2 when time is 0, because the initial height of the rocket is 0, the time is 0, and the initial velocity is 2. So the velocity will equal 2 at 0 seconds, and that's how we find the value of c. So then we plug in time at 80 seconds, because we're trying to find out which of the rockets is faster at 80 seconds. So we plug in 80 for t into the formula that we just found, and the answer will be 50. Rocket A, doing the same thing, you'll find that rocket A has a velocity of 49, which makes rocket B faster than rocket A by 1 foot per second. Yeah.
This isn't on the PowerPoint, but since it is noted that this one is a calculator problem, I'm going to explain how to use the calculator to solve this and saving you a lot more time. So you're already given the velocity of rocket A at 80 seconds, which is 49 feet per second. But you're also given the equation of acceleration for rocket B. And you are also given that the initial velocity of rocket B is 2. So knowing our integral rules, 2 is our initial, so it's 2 plus that integral of acceleration to find velocity at 80 seconds for rocket B. So you can plug in on your calculator 2 plus, then you click math 9, and then you set your bounds to 0 to 80 and plug in that equation of acceleration, 3 over the square root of t plus 1, and then you hit dx and you get 50. And it's exactly what we had gotten before, but now you've saved yourself a lot more time by just plugging a few numbers, and you still found that rocket B is moving at a faster velocity than rocket A at 80 seconds.
Thank you for listening.